Hello guys, welcome to another video. So in this video we are going to discuss on the topic named as consolidation. Since consolidation is an important topic in geotechnical engineering, they are asking every year questions on this topic. So let us solve the questions. If you see the first question, they are given that initial effective stress, that is initial effective stress or final effective stress before consolidation, which is 175 kilopascal, and final effective final void ratio before consolidation, that is 1.1, and they have given the total effective stress or total overburden stress after consolidation and void ratio after consolidation. They have asked us to find out the value of coefficient of volume compressibility. They have also given the thickness of the clay specimen, that is 25 mm. So let us calculate the coefficient of volume compressibility. The equation for coefficient of volume compressibility is given by mv, that is coefficient of volume compressibility, equal to AV divided by 1 plus E, where AV is coefficient of compressibility. Okay, so AV will be further derived by delta E divided by delta sigma naught dash divided by 1 plus E naught. Delta E will be equal to E naught dash minus E, that is 1.1 minus 0.9. So E naught dash minus E naught. So E naught will be equal to E, that is 0.9, and sigma dash plus delta sigma dash equal to 300, and sigma naught dash will be equal to 175. Therefore, delta sigma dash will be equal to 300 minus 175, which is nothing but 125. Now we will solve all this in this equation. So mv will be equal to delta E, which is nothing but 0.2 divided by delta sigma naught, 125 divided by 1 plus E naught is nothing but 1.1. 0.2 divided by 125 divided by 2.1. 0.2 divided by 2.1 into 125. By solving this, we get mv will be equal to 7.619 into 10 to the power minus 4 meter square per kilonewton. In this question, they have given that a water tank is to be constructed in the soil deposit with a footing of diameter 3 meter and depth 1 meter. And they have also given the load dispersion pattern as 2 vertical is to 1 horizontal. Also, they have given that the footing supports a load of 1500 kilonewton, and they are asking us to find out the expected settlement of the tank due to primary consolidation of the clay layer. So, primary consolidation of the clay layer acts at the center of the clay layer, just like this. Wait, acts at the center of the clay layer, and they are given a water tank. Water tank. So let us consider this as the water tank, and this is the footing. Where the width of diameter of footing is 3 meter and depth will be 1 meter. Load dispersion will be given by They have given load dispersion as 2 vertical, 1 horizontal, and the footing supports a unit load of 1500 kilonewton. See, water table starts at here. Okay, after silt is and water table is starting. And if you see the diagram, they have given the compression index 0.3, that is Cc, and initial void ratio, that is E naught, and coefficient of consolidation Cv is 0.004. Okay, now we'll write the solution. The equation of primary consolidation of the soil due to the load is given by delta H is equal to Cc H naught divided by 1 plus E naught log 10 sigma naught dash plus delta sigma naught dash divided by sigma naught dash, where Cc is the compression index, that is 0.3. H naught is the thickness of the clay layer, that is 10 meter. Here you should take the whole thickness of the clay layer. You should not take it at the middle of the clay layer. The effective stress will be acting at the middle of the clay layer. Okay. And 1 plus E naught initial void ratio, it is 0.7 log 10. So we need to find out the value of sigma naught dash, that is effective stress before application of load or effective stress before consolidation, and delta sigma naught dash, which is increase in effective stress. Delta sigma naught dash, or else change in effective stress due to the consolidation or application of the load. Okay, divided by sigma naught dash. So sigma naught dash will be given by, if you see this, the load dispersion is starting from 1 meter of the silt design. So it is bulk unit of silt design 15 into 1 plus, if you see the sand layer, they have given the saturated unit weight and water table is present. So the sand is in submerged condition. Okay. So which gives, means effective stress. How we will find effective stress? We will find by total stress minus pore water pressure. Okay. So we are directly calculating the effective stress. So we are taking the submerged unit weight. 18 minus 10, because pore water pressure at silt sand it is 0. 18 minus 10 into 6 plus 18 minus 10 into 5. We are calculating effective stress at the center of the clay layer. So sigma naught dash will be equal to 118 kilonewton per meter square. Now we need to calculate the change in effective stress due to application of the load. So if you see the diagram, the change in effective stress that we need to calculate will be given by the load by area at this particular point. Load by area at this particular point. So they have given the ratio 2 vertical is to 1 horizontal. For 2 vertical, we'll calculate the distance. So if you see this triangle, what a 2 vertical will be? This one will be 1 meter, This one will be 6 meter and this one will be 5 meter. Totally 12 meters. Okay. So it is total 12 meters, which is vertical by horizontal equal to 2 is to 1, whereas vertical it is 12 by horizontal 2 is to 1. Therefore, horizontal will be 12 by 2, which is 6 meters. Okay. So if this one is 6 meter and this one is 3 meter, also right side is 6 meters. Totally it is 15 meters. Therefore, stress will be equal to load by area. That is 1500 divided by area. They have given the diameter of the tank, so we have to calculate with respect to the recircular area. That is pi by 4 into d square, which is nothing but 3 plus 6 the whole square, where you get 8.488 kilonewton per meter square. Now, if we put these two values in the above equation, we get delta H will be equal to 0.3 into 10 divided by 1 plus 0.7 log 10, which is delta not sigma not dash, which will be equal to 118 plus 8.488 divided by 118, which gives 0.053236 meter. See, I have calculated all these previously, so I am writing down the answer very direct. Okay, equal to 53.236 mm. If you see this question, they have given a 20-meter thick clay layer is sandwiched between silty sand layer and gravelly sand layer. So we'll draw this one as clay layer, just 20 meters. It is sandwiched between silty sand layer and gravelly sand layer. Okay. So the layer experiences 30 mm settlement in 2 years. It experiences 30 mm settlement in the 2 years. And they have given the time factor equation. Okay. If the coefficient of consolidation CV is 0.003 centimeter per second per square per second, the deposit will experience a total of 50 mm. They're asking us to find out the number of years where the deposit will take a total settlement of 50 mm. And they have given, if you see this question, they have given the question as in the next dash years. In the next dash years means we have to consider the additional number of years that will make the clay settlement to 50 mm. We should not write down the total number of years. If you write down the total number of years, your answer will become wrong. You would have calculated the answer right, but if you write down the total number of years, they will not give you marks. So 2 marks will be lost for you. Okay. So you should see the question very carefully. In the next dash years, the next is the key point of this question. We'll start solving the solution. So the time factor equation, it is given by TV is equal to CVT divided by D square. CV is nothing but the coefficient of consolidation, T is the time period, and D is the thickness of the clay layer where consolidation is acting. So consolidation will be acting at the middle of the clay layer. Okay, we have to calculate consolidation at the middle of the clay layer. So TV equal to 0.003 into T is nothing but 2 into 365 into 24 into 60 into 60. 365 days, 24 hours, 60 minutes and 60 seconds. Divided by. So CV we have taken as centimeter. So with respect to, we have to take the thickness also, centimeter, divided by 20 by 2 into, it is given the meter, 1 meter is equal to 100 centimeter to 100 the whole square, where we get TV equal to 0.1892. So taking this TV in equation number 1, that is TV is equal to pi by 4 u by 100 whole square, which gives 0.1892 will be equal to pi by 4 u by 100 the whole square. By solving this equation, we get u will be equal to 0.4908, where this equation is for u lesser than or equal to 60%. So we got u is equal to 0.4908, that is 49.08%, which is less than 60%. Okay. So with this degree of consolidation, we can calculate the total consolidation or total settlement. That is total settlement for u is equal to 0.4908 will be, we have 30 mm in 2 years divided by 0.4908, which gives you 61.12 mm. So the soil deposit experiences a total settlement of 61.12 mm at 49.08 degree of consolidation. So they have asked us to find out the we need to find out the degree of consolidation for 50 mm settlement, which gives degree of consolidation for 50 mm settlement. That is nothing but u is equal to 50 divided by total consolidation, that is 61.12, which gives 0.818, nothing but 81.8%. So here degree of consolidation, it is 81.8%. With this we can calculate the time factor. The time factor equation is given by TV equal to 1.781 minus 0.933 log 10 100 minus u. 1.781 minus 0.933 log 10 100 minus 81.8, because here the consolidation is greater than 60% degree of consolidation. Okay, so with this we can calculate the time factor TV as 0.6053 0.60535, okay, which is nothing but seconds. Now with this we can calculate the time period. Sorry, this is time factor, right? Yes. With this we can calculate the time period, that is TV equal to CVT by T square, where TV is equal to 0.60535 equal to CV is nothing but 0.003, and we have to calculate for 50 mm, right? So we can change the centimeter into mm. We can change the centimeter into meter, because the thickness of clay layer is given in meters. One we can change with respect to meter, or we can change the meter into centimeter. Anything that is fine. Okay. Into T. We have to calculate T divided by, we can take this one, that is 10 into meter into 10 square, the whole square, which gives us 0.60535 into 10 power 6 divided by 0.003 equal to time period. So with this we get time period into seconds, because the coefficient of consolidation, it is centimeter square per second. Okay. So we have to calculate with respect to years. That is, T will be equal to 0.60535 into 10 to the power 6 divided by 0.003 into 60 minutes into, sorry, 60 seconds into 60 minutes into 24 hours into 365. Okay, which gives you TS 6.39 years. So the total years for 50 mm consolidation is 6.39 years, and they have asked us to find out the consolidation which settlement which acts which comes in the next dash years, means additional number of years required for 50 settlement. So the 30 settlement takes place in 30 took place in 2 years. So 50 took place in 6.39 in next 6.39 minus 2 years. Therefore, 50 settlement took place in next 4.39 years is the right answer. In this question, let us write down the given data. So they have given the given they have given average void ratio of 1.3, that is E equal to 1.3, and they have given the compression index CC equal to 0.6, coefficient of consolidation CV is equal to 1 meter square per year. Also, if you see the question, they have given this condition: increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure. So increase in vertical pressure due to foundation load, that is equal to the existing effective overburden pressure, means delta sigma naught dash should be equal to sigma naught dash, where this is the increase in vertical pressure due to foundation load and this is the existing effective overburden pressure. Now we will solve the question. So the equation of settlement is given by delta H is equal to Cc H naught divided by 1 plus E naught log 10 sigma naught dash plus delta sigma naught dash divided by sigma naught dash. E naught is nothing but the average void ratio. So delta H is equal to Cc, which is Cc is equal to zero point 0.6 into thickness of clay layer 4 divided by 1 plus E naught, that is 1.3 log 10 of sigma naught dash is equal to delta sigma naught. So sigma naught dash divided by sigma naught dash, which gives 0.6 into 4 divided by 2.3 log 10 of 2 sigma naught dash divided by sigma naught dash. So sigma naught dash will get cancelled. So from this we get 0.6 into 4, what it will come? 2.4 divided by 2.3 log 10 of 2, which gives 0.314 meter, that is 314 mm. 314 mm. In this question, they have given that the undisturbed soil sample from the middle of clay layer, that is 1.5 meter below the ground level, is taken, and the water table is situated above the clay layer, and they have given the certain parameters of the clay layer and sand. Also, they have given a compacted fill of 2.5 meter height with unit weight 20. There is nothing but surcharge or consolidation load something. Okay. So assuming unit weight of water as 10 kilonewton per meter cube, the ultimate consolidation settlement of the clay layer. So they are asking us to find out the ultimate consolidation settlement of the clay layer. So let us calculate the solution. Here they haven't given us the saturated unit weight of the clay layer, or they have given the bulk unit weight of the sand, but they haven't given the saturated unit weight of the clay layer. So let us first derive the saturated unit weight of the clay layer. So which is nothing but gamma sat will be equal to G plus E gamma W by 1 plus E. Also, they haven't given the void ratio, but they have given the natural water content of clay, that is 25%. So SC will be equal to WG, where S is equal to 1 into E will be equal to W, that is 0.25, 25% na 0.25 into specific gravity of clay, which is nothing but 2.7. So we get 0.675. So with this we can calculate the saturated unit weight. Gamma sat will be equal to G plus E by 1 plus E gamma W, that is nothing but 2.7 plus 0.675 divided by 1 plus 0.675 into gamma W, that is 10, which gives 20.15 kilonewton per meter square. Now we have to calculate the effective stress at the middle of the clay layer, that is middle of the clay layer, where the depth will be 0.5. So effective stress at middle of clay layer without surcharge. So surcharge, or it will come into change in effective stress. It will not come surcharge, so it will come into change in effective stress. So without change in effective stress, we need to calculate the effective stress at the middle of clay layer, which is nothing but sigma naught dash will be equal to sigma dash minus u. So total stress of sand and clay minus pore water pressure at sand and clay. That is total stress of sand will be equal to 1 into 17 plus pore water pressure of sand. So water table is not present on the sand, so it will be equal to 0. Sorry, minus pore water pressure plus total pressure of middle of clay, which is nothing but 0.5 into gamma sat, which is 0.5 into gamma saturated, which is 20.15 minus pore water pressure, that is 0.5 into 10. So with this we get the effective stress at middle of clay layer will be 22.075 kilonewton per meter square. Right. So with this they have given the 2.5 meter height of compacted fill with unit weight 20 kilonewton per meter cube, which is nothing but the change in effective stress. So due to compacted fill, change in effective stress. It is nothing but delta sigma naught dash will be equal to 2.5 into 20. It is nothing but 50 kilonewton per meter square. So therefore sigma naught dash plus delta sigma naught dash, that is total consolidation stress pressure will be equal to 22, sorry, 22.075 plus 50, which will be nothing but 72.075. So if you see the question, effect consolidation pressure, which is consolidation pressure changes from 20 22.075 kilopascal to 60 kilopascal. Kilopascal is nothing but kilonewton per meter square. Okay, and from 60 kilopascal to 72.075 kilopascal. So we are getting two consolidation stages at this state. So we need to calculate the consolidation settlement for primary and secondary consolidation like that. So total consolidation settlement delta H will be equal to H naught CR, that is recompression index, divided by 1 plus E naught log. So consolidation pressure varies from 22.075 to 60 at first stage, plus H naught compression index CC divided by 1 plus E naught log. So consolidation pressure varies from 60 to 72.075. 72.075 by 60. So delta H will be equal to H naught, that is 1 into 0.05 divided by 1 plus 0.675 log 60 by 22.075 plus h naught, that is 1 into zero point 0.5 divided by 1 plus, because previously we consider compression index and then we consider decompression index at the clay layer. 1 plus 0.675 log 72.075 divided by 60. So if you calculate this equation, you get delta H will be equal to 0.0367 m meter, which is nothing but 36.7 mm. 36.7 mm.